Okay, so in this video we are going to look at addition of two or more vectors, but we will look at addition of two vectors, and we'll continue from our previous video about components of a vector. So just a brief recap that in previous video we saw that if we have a vector, that vector, if you know its magnitude, which is like in, if I recall correctly, we had a force of 30 Newton and it was in XY plane and it made an angle of 35 degree with the x-axis. So if we have this vector force F equal to 30 Newton, we can break it into two components, one along the x-axis and one along the y-axis. One along the x-axis is known as, will be 30 times cos 35, which is equals to, we can use calculator to find that, and that's 24.57 Newton. And the other component which is along y-axis, and that will be Fy is equals to 30 sine 35, and we can again use the calculator to find its value, and this is 17.21 Newton. Just to remind you guys that whenever you are resolving a vector into two components, you will have to take cos for the component in the direction with which angle is given. So in our particular case, angle is given, angle 35 degree is given with the x-axis. So therefore our component fx will have cos 35 and other one will be sine 35. Right? So what we have seen here that we have broken this force F into two components. In other words, we have split this original force of 30 Newton into two components, into two parts. So one part is Fx and other part is Fy. So if we add these two vectors together, we should get our 30 Newton force back, which is to say that Fx plus Fy should give us F. And a quick calculation here will show that if we do a simple arithmetic addition, we add Fx here with Fy here, we get a value of 41 Newton, which is not equal to 30 Newton, which was our original vector. So as I noted in the last video that this sum here is not arithmetic sum, it is a vector sum. So we need vector sum here, and to emphasize that and to clarify that, I have to denote these quantities as vector quantities. So I'll put these arrows, so now it becomes a vector equation and it shows vector addition. All right, so the question arises, or rather we should say that we need to find out how to add these two forces to get our original force back. Yep. So we have to add these two vectors and we have to do a vector sum, and that's what this video is about. So when we add two vectors, we basically draw those vectors and then we put them in a chain. We draw one vector after the other. So let's see how it is done. My Fx is the force in x direction, and this is, if I have to draw that, I have to show that, I have to indicate that as a vector, then I can draw it like an arrow like this, and this is my Fx and its length is 24.57 and it is in the x direction. And likewise, if I have to show vector Fy, it is in the y direction. So this force will be, it can be represented by this straight line, this arrow, and the length here will be 17.21. Okay, when we want to add two vectors, we want to add Fx and Fy, then what we do is we draw one vector after other, with the second vector is starting from the tip of the first vector. So this is my Fx. Let me draw the Fx here. So this is my Fx. The length is 24.57. And then from here, from the tip of this first vector, I need to draw the second vector. Second vector is Fy. So that is my second vector. I draw it here. So this was 24.57. This is my Fx. This is my Fy, and that is 17.21. And the resultant vector, when you add them together, the resultant vector always is the vector which starts from the starting point and finishes at the tip of the last vector. So this is the last vector. I need to draw that. That is my resultant vector R. So all we need to do is, using trigonometry or whatever branch of maths you can think of, using that we need to find this length here, and then we need to find this angle. Just remember that because we are trying to find a vector quantity, we need to find magnitude as well as the direction. Magnitude will be indicated by the length, this length here, and the direction will be indicated by this angle theta here. It's a simple right angle triangle. This angle is 90 degrees, so we can very easily use Pythagoras theorem and elementary trigonometry. So R, using Pythagoras theorem, R is equals to the square root of 24.57 square plus 17.21 square. You can use the calculator and it will give you a value of 29.997. So it's basically rounding, little bit rounding error. So you got a 30 Newton, and that was the magnitude of our original vector F. But we need to find the direction as well. Remember that our direction of this 30 Newton force was 30 degrees from the x-axis. So we need to find this angle, and that angle should come out as 35 degrees. Again, we can use elementary trigonometry here. We can find tan theta in this triangle. So tan theta is equals to 17.21 divided by 24.57. That gives you theta is equals to tan inverse 17.21, and that angle, if you use your calculator, you will get this, so which is basically 35 degrees. So we see that when we split our original force of 30 Newton into two components, one component was this, other component was this, and they were in the direction of x and y axis respectively. And when we added these vectors together, we did a vector sum, and we got our original force back here. Now this method of adding vectors is scalable, which means that you can use it to add as many vectors as you want. So we'll not go into any calculation, but I can just show you. Suppose you got 3 vectors. So let me draw the vectors here. This is my F1, that's my F2, and you got the length as well. So let's say this is 10, this is 15, and the third one is, this is third one, which is F3, which is, say, again 15 Newton. If you want to add all these 3 vectors, F1 plus F2 plus F3, then we need to draw them in chain, and order doesn't matter. You can start with F2 and then F1 and F3, it doesn't matter. So we need to draw them in a sequence, just like we do in the previous example, and then we need to draw the final vector as starting from the starting point and finishing at the tip of the very last vector. So I can show you here. F1 is, this is my F1, so I'll draw, that's my F1. This is my starting point, and this is my F1. Now next vector, I should start from the tip of the first vector. So here, that's my F2. So that's my F2. This is F2, and the F3 is, it goes in this direction. So that's my, it's becoming a bit messy. That's my F3. Sorry. That's my F3. So you draw one vector, then you draw another one, then you draw another one, and that's my last vector. And the resultant will be from the starting point to the tip of the last vector. So my resultant vector is, that's my resultant vector. It's just to show the mechanism of adding vectors. And that's all in this video.